Imagine, we are the year 1800. Those days, the scientists enjoyed popularity the same way that rock artists this day enjoy popularity. The general public will go to listen to them speak. They will pay to buy a ticket to go and listen to them speak. They will sell out. These were the good old days. I am very glad that this eclipse gave us some way to experience the same feeling that these people had in the 1800s. Now, I should make sure, though, that I tell you that the 1800s, that was in England. That didn't start happening in the United States until the 1900, approximately. And that was because Edison was the one who made it so popular about the eclipse. That's how it went. That's how it started in the United States, too. Okay, so I have to control several things here. Yes. My name is Irene Guerinot, and my colleagues and I are thrilled that you are here, and you are going to be part of our discussion about the eclipse. Let me talk to you first about what we are going to discuss today. I am going to talk mostly about the project we are working with for Oak Ridge Associated Universities that has to do with the eclipse. What are we going to do? Why did they fund the project? I'm going to talk a little bit about what is a total solar eclipse and why is it so rare and why do we make such a big deal about it? Why have we sold up to this day, one company has sold 65 million pairs of eclipse glasses. It's great for the economy. It's not only great for us. It's great for the economy. Look at this gorgeous T-shirt. Okay, so back to the project. I'm always going on a tangent. So I'm going to talk about what we are working on and what the eclipse is all about. Dr. David Tolliver, an amazing friend of the college, a retired physicist and optics scientist with a master's and a PhD, is going to talk about what you are going to experience during the totality. Kathleen Stoller, biochem major, senior, is going to talk to you about the eclipse and the arts. She will concentrate on the visual arts and literature. Seidel Young, biochem major, sophomore, is going to talk to you about eclipses and the arts, and she's going to concentrate on music and then mythology. And Cameron Moore, guess what, biochem major, sophomore, is going to talk to you about safety and how to view the eclipse without hurting yourself. So it's going to be a wonderful experience. One more detail about Cameron. It's his birthday today. Okay, so we were in the 1800s. Let's go now back to, actually forward, to February of 2017, and we place ourselves in Atlanta. The American Association of Physics Teachers is holding a conference, their annual conference, and there are plenary sessions, oral presentations, posters. And Irene is attending that conference, and she's going from one to the other. 2-3 days. Approximately 60% of the topics had to do with the total solar eclipse. And after the first day, 2 major themes emerged discussed in the presentations. The first one was puzzling. The second one was extremely scary. The puzzling one was that in February, we were discussing that there are actually still people that did not know that a total solar eclipse was going to take place in August. But that didn't worry us because we are educators and we had a mission at that point. The second theme, trend, scary one, worried us very much because that is when I found out that there are a lot of counterfeit glasses already circulating in the United States. That was in February of 2017. In the conferences, in the sessions I was attending, they gave us two names, Rainbow Symphony and American Paper Optics. These were the two companies that we should get the glasses from. So for those of you that know me, and there are several people in the audience that know me, and they know how I am just so stubborn and so concentrating on something, and when I think about something, I cannot think of anything else, especially some of my past students, you will probably know that immediately I thought, okay, I have to write a proposal, and we have to go into our community and talk to the kids and talk to the teachers, whoever teacher wants to have us, go to the libraries and make sure that we are prepared, everybody gets excited, and at the same time we are watching the eclipse and we are very safe. So I'm thinking, who will give me money? Because I need money. That's what the whole proposal is all about. And I need students. And I need wonderful friends to help. There is an organization close by, has the headquarters in Oak Ridge, and they have been extremely nice to us, and they have funded a lot of crazy ideas. One of those crazy ideas was to do physics in an amusement park. And they were actually very happy to fund that. It's like, okay, so let's go and write a proposal for Oak Ridge Associated... I am failing. Oak Ridge Associated Universities. Put the request there that the main or a large percentage of the work is going to be done by students, and that I am going to just direct the students, and at the same time, I put in the proposal that there are people that are related to the college, that they are experts in astronomy, and that will be able to help us, and photography. And that was for Dr. Tolliver. And ORAU decided they were going to fund the proposal. The objectives of the proposal were, first of all, public engagement, public outreach, really. Go to schools, bring literature with us, discuss what is going to happen with the eclipse, discuss how we can see the eclipse in a safe way. The second part of the project was to actually do research, study mostly weather conditions, maybe even ionizing radiation to see if it is going to change in any fashion. So temperature changes, wind speeds, wind directions, barometric pressure, things like that. So thank you very much, Oak Ridge Associated Universities, for funding us. Before I continue, I would also like to say thank you to a few other people, like Brenda Ingle, our communications director, the safety person, the people that handle this auditorium that I have never given a presentation in this auditorium. It is wonderful to remember the scientists in the 1800s, but it's also kind of a little bit intimidating. Thank you for all your hard work. Thank you, Dr. Gibson, Dr. Siopsis, S-Cube program for helping us. Very nice, good students. Blount County Eye Center for donating glasses, and Vision for donating glasses. So in case you need an eye doctor, it will be a very nice gesture to go to this group if you don't have a favorite doctor already, as a thank you too, because they work for the community and we will give it back. Okay, I will try to see if anybody raises the hand. If I do not respond, yell. Who has seen a total solar eclipse? Okay. Would you like to tell us something about the total solar eclipse? First of all, where did you see it?
I was a high school student in Lubbock, Texas, back years ago. And we watched it from inside a large box.
Oh, yeah, yeah. And you? Wonderful. Okay, so both of you did the indirect method, basically, of watching the eclipse. Such a waste. All the lawyers are coming now, and okay. The total solar eclipse is, if you are in the United States, I will say the Super Bowl of the sky. If you are in Europe and South America, I'm going to say it is the World Cup of the sky. The total solar eclipse is a phenomenon that is going to touch every single one of your senses. If you feel like crying, it's okay. Go ahead and cry. I watched an eclipse, and I was very young. I was in elementary school. And I still remember it. I remember feeling, first of all, at some point I start thinking, is the sun ever going to come back? But there suddenly in the sky, you see that big black hole, and then you see the most amazing colors you have ever experienced in your life. And that is going to happen, as Dr. Tolliver will tell us in a little while, and basically you will have information 360 degrees. So, we will talk about the indirect method, and we will talk about the glasses. During the totality, you do not need the glasses. So during the totality, you're free to just look at the total eclipse. One thing that I will caution you is to try not to waste your time, take a picture. There are going to be people that are going to have tens of thousands, of hundreds of thousands worth of equipment. You cannot compete with those pictures. Well, you might, but... Also, another point to make. Cameron will talk about the safety of taking pictures or using telescopes. But another point to talk about the pictures. How many of you have been to Grand Canyon? How many of you have been to Cliffs of Moher? Can you show me one picture out of the millions that are out there that I will look at and I am going to get goosebumps and I'm going to start crying? Well, I might be crying because I won't have money to go there, but crying from the feeling that I'm going to get from that picture. So my advice to you is enjoy the experience. Don't try to take a picture. But there is so much information online. If you want to do that, that will be fine. There is a lot of information. There are many safe ways to watch the eclipse. Okay, so let's talk now about what is the total solar eclipse. First of all, every single eclipse, regardless if it is a solar, lunar, partial, total, annular, it doesn't matter. Every single eclipse involves shadows and involves three planetary bodies: the sun, the moon, and the earth. What defines each one of those eclipses is the location of those three bodies in relation to each other. So let's look at the total solar eclipse. We are going to have the moon getting in front of the sun, and then the shadow of the moon is going to reach the earth. Make sense? Okay. Now it's a little bit more complicated than that, because that is science. And everything is a little bit more complicated. But the initial point is that the moon will go in between and the shadow will fall on the earth, and there are some parts of the earth where the shadow is that you won't be able to see the sun. So let's look at the shadows. There are two shadows. There is this one that is called umbra. It's the one in the middle, and it is very narrow. And then there is the penumbra. It is wider, and it's on the outside. The observer that is going to be in the umbra is going to experience totality. The observer that is in the penumbra is going to experience partial eclipse. So if that is so simple, because they move in the same fashion all the time. The moon moves in an orbit around the Earth, and the Earth orbits the sun. So for them to align in that fashion, it should be pretty straightforward, right? So why are total solar eclipses so rare? Well, there are three parts that usually happen and then break the cycle, so we cannot have the total solar eclipse. The first one is that maybe the total solar eclipse actually took place, but it took place, this shadow, the umbra, was in the water, in the sea, and we didn't see it. So they do happen, but we don't see all of them, because the vast majority of Earth is water. So that is one of the reasons. The other reason is that the moon's elliptical orbit, which looks something like that, brings the moon sometimes very close to Earth when it is in the perigee, and sometimes very far away when it is the apogee. If they align, if the sun, the moon, and the Earth align, but in that particular case, the moon is located over here, the moon is not big enough, doesn't look big enough to cover the sun. So now I would like each one of you to bring your thumb in front of your eyes and position your thumb back and forth and try to see if you can block me, or most of me, my big head. Okay, where should it be? Should it be far away from you or close to you? Close to you. So do we see when the moon is over here and they are aligned, but the moon does not block the whole sun? That case, we call that total solar eclipse annular. In that particular case, you see a ring of fire around the moon. You are not going to see all these other wonderful things that Dr. Tolliver is going to talk to us about. So it's not a total solar eclipse. The third reason we don't see total solar eclipses is because the Earth rotates around the sun in an elliptical way as well. The moon rotates, but sometimes, most of the times, those two planes are not together. It's a 5-degree difference. So the moon is either higher than the Earth or lower than the Earth. In that particular case, if we go back to this one, I'm completely failing. If we go back to this one, if the moon is higher up, do you see how this umbra might miss the Earth altogether? If it is lower, it might miss the Earth altogether. Or it might give us a partial eclipse, which is very often what is happening. Okay, so, and why this particular one is such a big deal? The total solar eclipse, the last total solar eclipse that went through the whole United States from one end to the other, took place in 1918. If you were to look in this map, the orange line is the line of totality for August 21st. If you look at this particular line, it's kind of gray. It starts again very kind of close to Portland and goes across the whole United States. Do we see it? That was the last time that a total solar eclipse crossed the United States, and that was 1918. Total solar eclipse visible from some part of the United States happened in 1979, and that is over here. Do we see it? That is the 1979. Do we see the difference in the part of this path that is very wide. Our path is not wide at all. Our path, the width, is not even 68 miles. It's 67 something. The umbra for the eclipse on the 21st is going to cross the United States and move with average 2,100 miles per hour. That's extremely fast. And due to the rotation of the Earth in our location, it's going to look as 1250. Dr. Tolliver will talk about that as well when he covers his part. This particular eclipse will be visible only in the United States, in the mainland of the United States. It's not going to even be visible in an island. And such an event has not happened as long as we have been in the United States. This event has not happened as long as we have been United States as we know United States today. That is going to be visible only. I mean, we are so cool. Everybody else is a loser. It's our eclipse. That is why they keep on saying the American eclipse, because it's going to be visible only here. United States is going to get at least 100,000 visitors from other countries. That is a very mild estimate. Okay, so let's see what is going to happen in Tennessee. Remember, the umbra is coming from Portland, has gone through the other states, and then it's reaching Tennessee. This line that you see, this path, is the path of totality. Everybody else is going to see an eclipse. Whole United States is going to see an eclipse. But what type of eclipse is it going to be? A partial eclipse. Totality for us is going to start at, partial is going to start at 104. Totality will start at 233. It is going to be over in 97 seconds. And then the partial is going to be again, because it's going to go, the eclipse event is going to end around 4 o'clock. Looking at this part, every single city in this block is going to experience more or less the same thing. So for those of you that are thinking of traveling to the center line, the major advantage you will have will be it will last longer. You won't necessarily see much more stuff. There is a possibility, in some cases it happens, it's not 100% of the times, that the edges in which place we are on this part of the edge, it is possible for us to see many more things that the center line is not going to see actually. It's not always the case, but many times it is. At the same time, people that are on the other side of the edge might see things that we won't see. And now, I will turn it over to Dr. Tolliver.
Good evening. As Irene said, I'm David Tolliver, and I'm not the oldest student in the history of Maryville College. But I want to talk to you about a couple of things tonight. Most of my talk is going to be about the sequence of events and the phenomenology that will occur over the course of that 3-hour or so eclipse period. But first, I want to deliver a lecture on the fascinating subject of solar physics. At least it's fascinating to someone who's enjoying their 15 minutes of rock stardom. But actually, the eclipse reveals parts of the sun that we normally cannot see. So I wanted to explain a little bit about the structure of the sun and what it is that we're looking at, so you will understand a little better when you see it in real life. What do you think of when you think of looking at the sun, besides going blind? But suppose you're looking at a sunset. What does it look like? most of us would say a big orange or a big yellow ball, and maybe a bowling ball kind of thing. Well, that's a little bit misleading because the sun is actually a big blob of gas. It starts at a far distance as a very rarefied gas, just like the Earth's atmosphere, and as you get closer to the center of the sun, it gets more and more dense and hotter, and in fact, in the center of the sun, it sustains nuclear fusion reactions, which is what powers the whole sun. But it doesn't have a surface like the Earth does. There's no hard surface. And so why does it appear so sharp-edged? We can look into the sun and see through several layers of its atmosphere, just like if you were on the moon and looking at the Earth, you could see through the atmosphere and see the surface with the continents and the oceans and so forth. We can see a certain distance into this gaseous ball, and what we see is called the photosphere, and that's the familiar orange ball of the sun. We can't see any deeper into the sun because of the density there. It just gets so opaque. And the photosphere is very thin. It's only about 240 miles thick, and so that gives rise to, makes it look like a very sharp edge to us. By the way, the word photosphere means sphere of light, and obviously that's a very good terminology because it's spherical and it is very bright light. The photosphere is about, on the average, 5,700 degrees, and that's pretty hot, but as we'll see later, that's not super duper hot. The photosphere does have some structures. I've been told by people who have better eyes than I do that sometimes they can actually see at a sunset or something a very large sunspot. There are sunspots that travel across the sun there. Most of us would probably need binoculars or a telescope to see those. But by the way, if you're going to try to do that, make sure you have filters on the outside of your optics. Do not try to hold a pair of binoculars up in front of your solar viewing glasses. The binoculars will amplify the light hundreds of times, and in fact may burn through the glasses film and injure your eyes. So be sure you always have your filter on the front of your optics. The sunspots rise and fall in an 11-year cycle. At the maximum of a cycle, there may be 200 sunspots observed in a year. At the minimum of a cycle, it could be 0. We had kind of a secondary small maximum in 2013, and so we're on our way towards a sunspot minimum. In my practice photography of the sun the last couple of weeks, I've only seen one sunspot, so we're not having much sunspot activity going on right now. Above the photosphere is the first layer of the sun's atmosphere that is called the chromosphere. Chromosphere means sphere of color. In this case, the color is red. The chromosphere is also pretty thin. It's about 1,200 miles thick. It's a very active, dynamic place. A lot of things going on. I mentioned that the sun is powered by nuclear reactions deep in the interior. The other major energetic activity of the sun is its magnetic field. It generates a very, very large, many thousands of times larger than the Earth's magnetic field. And being a ball of gas, it does not rotate as a solid sphere like the Earth does, but the equatorial regions rotate about once every 25 days, and the polar regions might rotate about once every 36 days. And so these magnetic fields are always getting stretched and twisted and tangled and braided all up, and it's like stretching a rubber band. And sometimes you just go too far and the rubber band snaps, and the magnetic fields undergo what's called a reconnection event, which goes back to a lower energy, simpler state, and it gives up tremendous amounts of energy when that happens. And that is manifested by various local storms, if you will, on the sun's surface, including the sunspots. In the chromosphere, we have filaments and prominences. A filament is observed against the photosphere. A filament looks like a kind of a long, dark, fuzzy tube of cooler gas. a little darker. And if it goes over the edge of the sun, you can see that it loops out into space like a big loop. And you can maybe see some of them here. There's also spicules, which are vertical jets of gas coming up through the chromosphere. And sometimes these magnetic reconnection events can cause solar flares, which is like a plasma explosion. The chromosphere starts out at its base at about 4,400 degrees, and at the top it rises to about 10,000 degrees. Yes, it gets hotter as it goes farther out. Above the chromosphere is the solar corona. The corona extends many, many millions of miles beyond the sun. I should have said both. The photosphere is the only part of the sun that's visible normally, and the chromosphere and the corona are only visible during eclipse, total eclipse events. The corona is very hot, maybe 1 or 2 million degrees. It's also very dynamic and changes. It has streamers, and its configuration looks different for every eclipse. And sometimes these prominences can have enough energy to extend into the corona, and they can break and spew a bunch of atomic particles into space in an event called a corona mass ejection. If the Earth happens to be in the path of one of these particles can interact with the Earth's magnetic field and cause geomagnetic storms, which can pump up the aurora, give us very beautiful aurora, can damage satellites in Earth orbit and disrupt communications around the world. So that's the lecture on solar physics. The three main parts of the sun are the photosphere, which we can see every day, the chromosphere, and the corona, which can only be seen during eclipses. So I want to walk through the phenomenology of what we will be able to see, assuming we have good weather, on eclipse day, and some of the terminology. First contact is when the leading edge of the moon first touches the leading edge of the sun. They're actually, by the way, going in different directions in the sky. The sun is headed west, and the moon is actually headed east. And when they first touch, it is called first contact, or C1, and that's going to happen here at 1:04 and 57 seconds. And by the way, that time is the appropriate time for the center of the 50-yard line at Maryville College football field. And this is the beginning of the eclipse event, starting off the partial eclipse phase, and the sun's disk starts becoming a crescent. And you can see this picture here is just a few moments after the first contact. The first contact, the first partial eclipse phase will last about an hour and 28 minutes. Because we don't have the heating, the temperature is likely to fall, maybe as much as 10 degrees. The winds may pick up. The barometric pressure may change. If you're in a place where there are animals around, they might start exhibiting very odd behavior for the middle of the afternoon. Cattle might head for the barn. Birds might quieten up and quit chirping and head to roost. If you're experiencing this, kind of keep an eye on the western horizon. That's where the umbra is going to be coming towards us. During this partial phase, of course, we're in the partial shadow, the penumbra, and as we get closer in, the shadow increases. But this umbra will be coming at us at about 1,250 miles an hour, so it'll come at us and cover us up. We may be able to see this phenomenon called shadow bands, and I'm really excited to look at this. I've never observed anything like this. It's associated when the disk of the sun gets very, very thin crescent to almost become a point source of light. And it shows up as undulating patterns, lines of light and dark illumination that you can see on kind of light or smooth surfaces, like a sheet on the ground, or in this artist's depictions on the side of a house, or I've seen photographs of on the side of an automobile. And this is caused by scintillation in the atmosphere. It's kind of like looking at the bottom of a swimming pool with some little waves on the top, and you can see the little lines rippling along the bottom of the pool. A very similar thing is going on. And this only happens for about a minute, literally 60 seconds before second contact, C2. This eclipse is going to start, all eclipses start out very slowly, with this first phase lasting an hour and a half almost. But as we get to totality, things are going to pick up and start happening on a second-by-second basis. So this is one of the reasons with trying to photograph the thing. It's happening so fast, and if you blink, you'll miss it. If you're not paying attention, if you're chatting with your neighbor, you're going to miss some of these things. In fact, there's so many things going on in so many different directions, it's probably impossible for one person to observe all of them. So I'm kind of listing them here, and you can pick what you want to look for. But maybe 10 or 15 seconds before second contact, which is when the edge of the sun or the edge of the moon covers the trailing edge of the sun, and the moon is completely covering the sun. About 10 or 15 seconds before that happens, we may be able to see the diamond ring effect, which looks like this. How many? Does that look familiar to anybody? That was the logo of the TV series, and it figured in some places in the show Heroes from a few years back. And what it is the last bit of the solar crescent, as it's shrinking down, is popping through on one side of the sun, and a little bit of the chromosphere is observable around the edge, forming the ring. Then, a mere 3 to 5 seconds before contact 2 occurs, we may be able to see a phenomenon called Bailey's beads. Of course, the edge of the moon is not perfectly smooth, like a bowling ball. The moon has terrain on it, mountains and valleys. And so as the edge of the moon, the rough edge of the moon covers up the sun, there will be mountains that block the view in some places, and valleys which allow the sun to shine through. And those show up as a series of little dark bands and beads around the crescent there. And if there's a consolation for us not being right on the center of the path of totality and getting the whole length, the Bailey's beads might persist a little more at where we are. And then, oops, I'm going the wrong way. And then second contact occurs, and that will happen at 2:33 and 52 seconds. And again, that's just as the moon completely covers up the sun, and we're now in the period of totality. For a few seconds after that, after C2, we should be able to see the chromosphere as a thin red ring all the way around the sun. And I chose this blown up picture here. Kind of you can see the glow all the way around here. But these red parts here, this one is detached. These are prominences. And so if we're lucky, we may be able to see some prominences. If there's anything going on, which doesn't seem very likely, there might be also some solar flares or corona mass injection, and so forth. Now we've entered the period of totality, which, as was mentioned earlier, will last 97 seconds. And if you're trying to observe that, that's not very long. But the solar corona will be visible for the duration of the totality. And I've never seen a total eclipse, but this should be pretty dramatic. The corona will extend for several solar radii. In fact, the corona hardly ever ends. You could think of the Earth as it's orbiting the sun at a distance of 93 million miles, is kind of swimming through some of the very rarefied vestiges of the corona. Of course, as it goes farther out, it gets dimmer and dimmer. Right in close to the edge of the moon here, it will be as bright as looking at the full moon on a full moon night. And it will trail off as you go from there. The corona, as I said, is very dynamic. It's always changing. It never looks the same in two eclipses. And you can see there's these streamers and striations, and you can kind of see these loops where the magnetic field is confining it. But if you can tear your gaze away from the sky, you might want to look around the Earth, around the horizon. We should be able to see twilight, sunset colors, 360 degrees all the way around us. And the reason is we're here in the totality in the umbra, which is dark, and that region over there is out in the penumbra, with the twilight area. So it's going to look like 360 degree sunset all around us. Depending on how clear the atmosphere is, we may be able to see the earth shine. And it barely shows up on this slide. Of course, we know the moon has light and dark features on it there and some structure to it. It may be visible because of earth shine. Earth shine is the light of the sun reflecting off the earth and illuminating the dark side of the moon. There's going to be a lot of contrast between the very bright corona around here and the earth shine, and it takes a very clear atmosphere to see that. Also, during totality, because it's dark, you should be able to see some other celestial bodies. The planet Jupiter, which is one of the brightest planets, will be over here about 75 degrees to the east of the sun. Should be easily visible. The planet Mercury is right here going to be some 18 degrees east. Mercury is very small, very dim, and so we may or may not be able to see it. The planet Mars is on the other side, on the west here, about 18 degrees to the west. It too may be obscured by the corona. However, Mars is a orangish red color, and that might help us distinguish it from the whitish corona light. And then finally, farther over to the west is another very bright planet Venus. You should be able to see some stars also. The star Regulus is right here in close, only about 3 degrees away from the sun moon. Does anybody know, any Harry Potter fans know who Regulus was? He was the brother of Harry Potter's friend Sirius Black. And the brother star, Sirius, is one of the brightest stars in the winter sky. Will also be visible, but he's going to be way over here towards the horizon somewhere. So as I said, the duration of the totality is only 1 minute 37 seconds, but then we get to see an encore. All the phenomenology I've talked about is going to be repeated in the reverse order. As the sun starts to emerge from the back of the moon, we come to third contact, C3, which will occur at 2 minutes 35 seconds, 2 o'clock, 2:35 and 29 seconds. And then the totality is over and the second partial eclipse phase begins. And we'll go through the same phenomenology of the shadow bands, the chromosphere, and the diamond ring, and those will occur in just the opposite sequence. And then finally, the whole show is over at fourth contact, where the moon completely clears the sun, and the sun is a full disk again, and that will occur for us at 3:59 and 3 seconds, and that's the end of the eclipse event. So I think we're going to stay around later. If anybody has any questions, we'll try to answer them. So now Kathleen's going to tell us about what humans throughout history have thought about eclipses as they've observed them.
All right, so we're all really excited to see this eclipse. We're just looking forward to it. We're really happy that we get to see it. But that hasn't always been the case for civilizations in the past. Most civilizations saw the eclipse as a harbinger of bad news. They thought that their world was going to end. They didn't know if the sun was ever going to return. So this image here is of the Dresden Codex. It is one of only 4 Mayan manuscripts that are left. It's the oldest and best preserved. When it's completely opened up, it's actually like 12 feet long, so it's a really big piece of paper. It has ritual and divination calendars. It has descriptions of locations where they thought the rain god existed. And then it also has predictions of when solar and lunar eclipses would happen. They were really concerned with being able to predict eclipses so that they could prepare their citizens and their people to be able to do whatever they needed to do to get the solar eclipse to leave, because they didn't like it. This is an image of a funerary vase from China, 13th century-ish. They have a specific myth about a great dragon eating the sun. So Chinese culture also worked really hard to be able to predict when the eclipses would happen so that they could have their citizens be outside and make lots and lots of noise to scare off the great dragon so it wouldn't eat the sun. The Chinese word for lunar eclipse and solar eclipse both end in the character that means eat. So the myth clearly influenced how they developed their language. This image here is much more modern. This is a painting from the 20th century. It's by an American artist. He painted 2 works based on the eclipse. This one, it's a little more positive. It doesn't have the, oh, bad news is coming. It's still a little chaotic, but it's not a negative view on the eclipse like the old civilizations had. This picture here in the middle is another one from an older civilization. This is based off of the Zapotec mythology from Mexico. And Tamayo just worked really hard to be able to capture the chaos and the hopelessness and helplessness that they felt when an eclipse would happen. Because that's just, they thought their world was ending. They didn't think that they would survive the eclipse. This picture here by a psalm, the vision of Saint Benedict. So Saint Benedict was said to have had a vision of the entire world gathered under a sunbeam. So this artist, in order to make the religious experience more accessible to people, he depicted it as an eclipse. And so this here is almost like a depiction of the diamond ring effect, and he just extended the sunbeam so as to depict what they said St. Benedict saw. And a lot of art historians are very amazed with the detail in the corona and other solar details that they put in. And then this picture here is probably my favorite. So this is another American artist. Howard Butler was actually able to be at 4 different eclipses. He painted 4 different eclipses. And so this is, again, in late 19th, early 20th century. So he had to travel by probably horse and buggy at first, and maybe a car later, if he was lucky. The first 3 he had to go to. So he didn't just happen to pick one spot where 4 eclipses happened. He had to go chase them. And then he was lucky enough, the 4th one happened right where he was. So he got to paint the eclipse from his back porch. But after his first painting, scientists and astronomers came up to him and they were like, how did you paint exactly what I saw? Because he got the colors, he got the corona, he got the diamond ring. Totality only lasts for, if you're at the perfect eclipse, in the perfect spot, the most you will ever see totality for is 7 minutes. We here in Maryville are only going to see it for 97 seconds. Can you imagine recording enough information to be able to paint that later? You only get to see it for 97 seconds. So scientists were really, really impressed with his ability to recreate exactly what they saw. And this is one of the best records of eclipses up until photography caught up and was able to record a whole lot better. All right, so literature has a lot of same themes of the visual arts from early in time. So we see more themes of fear, destruction, and just hoping for the eclipse to go away. These are just a couple excerpts of a couple works. Of course, the Bible verse, it was now about the 6th hour, and darkness fell over the land until the 9th hour, because the sun was obscured and the veil of the temple was torn in two. So again, it's not a very happy feeling. It's very, very negative, and it's only just now changing to a happy and excited thing to see the solar eclipse. All right, and now Seidel is going to talk to us about music and mythology.
Since the solar eclipse only lasts 97 seconds, or a little longer depending on your location, it was kind of hard for people to come up with different ways to express the solar eclipse. And so there's not many songs about the solar eclipse, but a couple of them are You're So Vain by Carly Simon, Eclipse by Pink Floyd, and of course the most popular, Total Eclipse of the Heart by Bonnie Tyler. Another way that music is being related to the solar eclipse is by the Kronos String Quartet, and they're assisting in using sonification to basically transition the lights from the solar eclipse into like a sonic experience or instrumental and type of song. I think that's really cool. So, as Kathleen explained, the solar eclipse was thought of with fear and destruction, and we can also see this pattern continue into the different myths that people came up with in different cultures. So, in most of the myths, you can see or it's described as something eating the sun. In the Chinese culture, for example, they thought that the dragon was eating the sun. In Vietnam, they thought that a giant frog was devouring the sun. And then in Europe, the Vikings thought that wolves were actually eating the sun. Also in Hindu, they thought of the evil demon ORAU, and he was getting punished for drinking the nectar of the gods. So he was beheaded, and they imagined that his head was still alive, so it rolled up into the sky and ate the sun. And so like Kathleen explained, during the solar eclipse, they would ring and bang loud pots and pans to try to get this demon or these animals to stop eating the sun. Another myth is in the Middle East, in Iran, as you can see in this picture. There was an old lady. She was carrying a sack, and she was like, wow, it's a hot day. I'm going to take the sun and put it in my sack. And so she didn't know that there was a hole in the sack that she was carrying, so the sun just rolled out and went back up in the sky. Another myth is in ancient Greece, and they thought of the eclipse as the gods giving them a sign that they were mad at them. So that's why the word abandonment in ancient Greece is actually eclipse, and we use that without realizing it. But in ancient Greece, they thought of it as destruction, as being punished by the gods. In West Africa, their way of thinking of the eclipse is the moon and the sun being in conflict. So during the eclipse on the town, they will all try to settle their differences and get along to try to make the eclipse stop. And they also use this as kind of like a story or a way to raise children by saying during the solar eclipse, the sun and the moon are in conflict, so we all need to get along and settle our differences. And some of these myths still last now. In India, I know some people still like to fast during the solar eclipse because they believe that if they cook during this time or if they eat during this time, they'll be poisoned. And so, solar eclipse was thought of fear and destruction, but now we've came into the time where it's exciting and it's amazing. So now to the most important part of this presentation, safety by Cameron.
So from ancient civilization till now, the sun and the moon and the earth have been such an important part of our culture and the way that we think about things. And in today's times, we really think of them in a very positive light. But we can't always do that because when we're viewing things like the solar eclipse, we have to be careful. So let's just start with the sun. The sun is really bright and it produces quite a bit of the visible light that lights up our world and allows us to live our everyday lives. But the sun also produces radiation, specifically like ultraviolet radiation, or as we know it, UV. So just think about the worst sunburn you've ever had in your entire life. You get blisters and you turn red. It's not fun. Now, if we think about our skin, comparative to other parts of our body, such as our eye, it's pretty tough. So when you think about your eye, just imagine if a sunburn on your skin can look like that, imagine what it looks like in there. So we have to find a way to protect ourselves. And there are many different ways you can do that. The first is through solar eclipse glasses like these. So what makes these glasses special in comparison to, say, my glasses or sunglasses? These glasses are covered with a film, polymer of sorts, that blocks out all other light, including the bad light from the sun. The only thing that these glasses will transmit is light from the sun. So it is protecting our eyes and keeping us safe while we watch the eclipse. Now, the first thing you have to do when you think about these glasses is make sure that they are approved, manufactured properly. A lot of things going on in the media today, we know that there are many manufacturers who are making false glasses. So we have to check and make sure that these glasses actually are approved and work. So the first thing you need to look for is the ISO number. The International Standards Organization gives the number to the approved glasses, and this number is 12312-2. Now, originally this number was like the tell-all these glasses work, but in more recent events we've heard that a lot of manufacturers are printing this without them actually being approved. So you have to look for the appropriate manufacturers. So if you go to the NASA website, there's a link to it talks all about the eclipse with all this wonderful information, and there's another link that takes you to a list of approved manufacturers such as American Paper Optics and Rainbow Symphony. And you can tell by reading the glasses, it will tell you the manufacturer, things like that, and you can find if there's an appropriate manufacturer for your glasses. Now this doesn't, end all here. You have to make sure that your glasses actually work. So the way that we've been telling people to do it is you have to put your glasses on before the eclipse actually starts. You have to practice. So what I've been telling people a lot is you take your glasses and you put them over your face, and if you see absolutely nothing, they work. So the only thing you can really see with these glasses is the light from the sun. Now, if you happen to find that you can see light coming through these glasses through a hole, a scratch, something like that, that means that your glasses are defective, broken, something like that. So you need to throw them away immediately and get new glasses. You also need to make sure that you know how to put your glasses on before you go to view the eclipse. So most people make the mistake of looking at the sun first and then putting the glasses on. If you do that, you are already accruing damage to your eyes. So you need to make sure that you don't look at the sun before you put the glasses on. So what I would do is look down, put the glasses on, and then look up, and then view the eclipse. And once it's over, make sure you take the glasses off looking away from the sun. Now, if you happen to find that a couple days before the eclipse is meant to happen, you've lost your glasses are broken, and as we know, they're selling like hotcakes, so you probably can't find anymore. There are other methods that you can use to view the eclipse, such as a pinhole projector. So these pinhole projectors are pretty simple to make. You just put a hole in a box, surround that hole with tin foil, and then inside the box you'll put a white piece of paper, and if you aim, let's say the sun's back here, you aim the pinhole toward the sun, you put it over your head, and you look inside, and you'll be able to see the eclipse in a very indirect way, and you can watch as the light changes. So as the moon crosses over, you'll be able to see it go to totality. You can take it off, look at the totality, and then watch as it disappears. Now there are also other ways that you can do this. Let's see if I can work this thing. All right, so here. So what you can see is in that picture right there, you'll see that people can view it through a tree. So let's say you don't have the box and the tinfoil and all the things you need. All you would have to do is go under a tree that's pretty open and has a lot of, openings in the leaves, and you can watch the same effect as you would in the box. And then there's a similar method using a colander or a slotted spoon, and you can do that same thing watching as the sun crosses. All right. So This is a list of resources that we've been using just throughout our research and throughout this whole time, and we think this would be of value to you. Don't worry about taking pictures or writing them down. We have handouts out in the lobby, and so you can get those and make sure if you forget a lot of this in a couple days, you can have it at your disposal. All right, I guess without further ado, we'll start our question and answers portion.
I suppose if anybody has a question, raise your hand and we'll get the microphone to you.
Was the time phase just for the 50-yard line, or was that for the whole area?
That was strictly for the 50-yard line. It will vary by, seconds depending on where you are in the area. One excellent way, if you really want to know, I found an app for the iPhone and Android called Solar Eclipse Timer. So you go to the App Store and search on that, and you'll find it there. And it's maybe $2, and it's very easy to use. You go to the location in the path of totality that you're going to be. You push a button that says "Locate me." It determines your GPS coordinates. You push a button that says "Load times," and it will tell you the times of all these 4 contact points. Tell you the midpoint of totality, and it will give you verbal announcements, 60 seconds to contact 1, and it will give you some hints as to what to look for.
Is there a way to test these knockoff glasses to see if they're safe?
I guess if you look at the sun momentarily, put the glasses on, look at the sun momentarily, because we do that on our everyday life. We're not going to look at the sun for an hour or 20 minutes. If you just see a little bit of light, probably they're okay, but I'm not really sure. Maybe an eye doctor can say that better. I don't know, because what the real glass is supposed to do, they're supposed to completely block UV and IR and 0.000 and only allow 0.001% of sunlight, visible light, to go through. I cannot think of something else.
How large in the sky will the eclipse be? Will it look like a full moon, or how comparatively?
It will be the same size as the sun and the moon are normally, about a half a degree. And it will be located fairly high, about 65 degrees elevation angle, which actually looks much more towards the vertical than you might think it is. It's going to be very high in the sky, but it'll be about the same size. It will be the same size as always. In fact, I did some research here that in this case, for this eclipse, the moon will appear to be 1.03 times bigger than the sun, so only 3% larger than the sun. And that's why the band of totality is so narrow for this eclipse.
Question for Dr. Tolliver here. You said that the temperature of the sun increases significantly as you move away from the surface of the sun. Is there an easy explanation for why that happens?
No, in fact, that's one of the unresolved mysteries of solar physics today. It's not really well understood. There's several theories been put forward, but none of them completely explains everything that's going on there. So that's still an open question.
Dr. Tolliver, so if we come and sit out on the Maryville College football field the day of the event, are you going to be up on the PA system giving us a play-by-play of every step?
Actually, yes, I am. I will tell you, as we get closer to totality, and things start happening really fast, I'm going to stop talking. I won't be able to keep up, and so you're going to be on your own to try to be familiar with these things and know when to look for at what time.
I have a question. Does the solar eclipse, the full solar eclipse, have an effect on the tidal waves?
Yeah. There is a theory. Where are you, Anna? There is a theory that says so, but it's one of those parts of science that they're still investigating. There are many things that are going to be studied during the eclipse, and that's the only time that they can study them.
So my next, I have a question. I'm still a little bit unclear about when to wear the glasses. Are we supposed to put them on at 1:04, take them off for 97 seconds, and then put them back on until 4 o'clock? Is that what we're supposed to do?
Right. If you want to watch the whole eclipse at 1:04, if you want to look at the sun at 1:04 and start seeing what is changing, then you have to have the glasses on. And then when totality happens, you won't be able to see anything, so you take the glasses off, or you can use the app also that David was talking about. It will tell you that totality is happening. Then you can take them off. So you can have the glasses off only for the 97 seconds. They should be on all the time, before and after.
That's only when you're looking at the sun.
Yeah, only when you're looking at the sun.
If you're just walking around, you're okay.
Yeah, you're perfectly fine. There's nothing different.
Walking in walls.
Yeah. Now, there is a possibility that some of you have older eclipse glasses, or even the ones that they have printed now, and they're good glasses, but they might still have the old warning that was saying that you cannot look at the sun for longer than 3 minutes. You have to take them off. This was the old technology. You don't have to worry about the ones that are manufactured right now. The old ones were also saying that after 3 years, you have to dispose of them. That doesn't apply to the new technology. You can go to NASA's website and they have all this information there. And the ones that we are going to distribute today have all the requirements and all the standards of the latest technology. So you can keep them on the whole time, look at the sun for the whole 3 hours almost. Well, not the 97 seconds, but everything.
But a good rule of thumb there is if you want to look at the sun and there is any sliver, any tiny part of the photosphere, the bright part of the sun, showing, you need to be wearing your glasses. And that includes the diamond ring effect and the Bailey's bead. It's only when the bright sphere of the sun is completely covered by the moon is it safe to take the glasses off and look with your naked eye.
If you wear glasses, regular glasses, do you put the solar glasses over your glasses, or you have to take your glasses off?
We recommend you keep on putting the glasses under just so they won't fall off when you're watching the solar eclipse or when you're looking up. But if you wear regular glasses, I think it would be better just kind of put them under just so they can safely stay on your eyes.
It's really your personal preference. Whatever works for you.
Probably a whole lot more than we technically do. So you really don't need to worry about your pets. They won't look at the sun.
Is there much of a chance to see solar flare activity during totality this time?
There's a chance. I'd say it's probably pretty low just because the solar activity is very low right now.
If I might, it's not a question but a comment. I was doing a little research on this just the other night about what can you see through these glasses. And you can see comparable things to the brightness of the sun. Like we were looking up at the filaments of an unfrosted bulb, and you could just see the filament. Or if you look right into a very bright flashlight, you can see just a smidgen of a light through there. So you can actually see a few things, but very, very little.
If the weather is inclement, what should we expect to be able to see if it's pretty cloudy?
My first answer to that question would be that the weather is going to be perfect. I would so much like to have control over the situation. So much. You don't know how much. That since I have no control over the situation, I'm going to believe, and my belief is going to be that the weather is going to be perfect. However, what has been observed is that during an eclipse, when there are clouds on the sky, clouds many times start dispersing. But every eclipse is very different than the other eclipse, so some things that many people have observed in the past might not be happening, but that is what they say. Clouds could start dispersing. If you can travel, then you might want to travel 4, 5, 6 hours somewhere where the weather prediction is a little bit better than here. If you're stuck here, believe. It's going to be perfect.
It depends on what the cloud cover is. If we have some high, wispy clouds, we're probably going to be able to see much of the same things here, probably not some of the smaller, more subtle effects. But if there's a front coming through and we're socked in like it was yesterday, it's probably just going to get dark. And the only effects we'll be able to see is to watch the animals and see if they go to bed.
Can you comment on the risk of the difference between what we face in the area of totality versus hundreds of miles away where it's apart? How much more intense is the risk for us or less intense for people 100 and 200 miles away?
What do you mean?
Well, again, anytime you can see a part of the photosphere, the bright part of the sun, you don't want to stare at it. You'll damage your eyes or your camera. And so that's why when it's completely obliterated, we're perfectly safe without the glasses. The people in the partial zone only never get to experience the totality. So if they're looking at the sun, they need to wear the glasses every time they look at it.
And something else here related a little bit to that. 97% is not equal to 100%. I mean, that is usual math, everybody knows that. But as far as the eclipse is concerned, 99% has an incredibly huge difference to 100%. A lot of people that have experienced total solar eclipses will equate to you going to a theater to watch a musical. The musical takes place over here, and you wait outside. Outside is the 99%, here is the totality. You see what they're... So, if you're in Knoxville, come this way.
So when the totality happens, no light will be visible from the sun or
That's correct. No light will be visible from the photosphere of the sun, what we normally think of the sun. For a brief period, we'll see the light from the chromosphere, and then for the duration of totality, we'll see the light from the corona, which close in will be about as bright as the full moon.
So we can look at the light from the corona?
Absolutely.
Okay.
Yeah. During totality, you're safe. In fact, it's so dim you won't be able to see it through the glasses.
You mentioned cameras and telescopes, and if you went through one of the approved sites through NASA and bought a filter for your camera and or your telescope, you should still be able to use those. And if you wanted to attempt photographs, simply putting it on an iPod and on a tripod and standing there clicking while you're still looking up should be all right, as long as you've got that filter on your camera.
Yes, that's what those are designed for. But again, it has to be out in the front of your lens. I've done a lot of research on how to photograph an eclipse, and said, if this is your first total eclipse, just enjoy it. Don't try to photograph it. You'll miss it. You'll miss too much. But it probably says something about my personality. I don't try to photograph it. But I will say I have done many hours of research. I have been out practicing shooting the sun at eclipse time in the afternoons when it's not being cloudy. I have a written shooting and exposure plan that I'm going to follow, and it's kind of a script. I say, okay, I'm going to change this camera setting here, and go through it. And I tell you, I'm still worried it's going to be very frantic in those 97 seconds and the few seconds before and afterwards. So I'm thinking I'm going to have it down well enough that I can execute my plan and still look up and see what's going on occasionally. I have read that you can use the solar glasses and put them on the front of your iPhone camera, because that's a tiny little lens on the front of the camera, and take pictures that way. I have no experience. I don't think anybody has experience photographing an eclipse through my phone. I've been around long enough. But there are experts on the internet that says you can do that, so it must be true.
I learned the story of a gentleman who is considered to have the record of how many eclipses he has watched, and I think the record is 34, and I don't think there's anybody who has watched more eclipses than this gentleman. This gentleman started like David. He was going to photograph the first eclipse. He had the whole list, and he was absolutely prepared. He knew exactly what he was going to do, bought the right equipment. The total solar eclipse starts, and apparently this gentleman is completely frozen. Yeah. Completely frozen. He didn't photograph nothing. And then the chase started. After that, he just was going one eclipse after another. That's why he has the record. So I think we should help you also make sure that you reach your goal and you're going to photograph something. So it's like, David, tell us what we need to do, we will help you, because we don't want you to be like that gentleman that will be frozen.
I have done a lot of research. I can recommend two websites if you're really convinced, stubborn like me, that you want to try that. One is by a gentleman, an amateur astronomer named Jerry Lodriguez, Lodrigues, and he has a blog with the name Astropix, Astropix in the title. So if you do a search on eclipse photography Astropix, you'll find a multi-page treatise on how to do it. The other source that I have used was from the current issue of Sky and Telescope magazine. And actually, I saw that magazine down at the Blount County Library, and I Xeroxed the 4 or 5 page article out of that. And those two are the best references I found if you really want to try something like that. And they pretty much agree with each other, unlike a lot of the others on the internet.
You mentioned emotions. I know with a full moon, extra security's put on, maternity wards are busy. Are those sorts of things expected with the eclipse?
No. They say that none of these are going to be affected for real. A lot of people believe that pregnant women are going to experience certain things that wouldn't have been experienced otherwise, but the medical field does not agree with those observations.
Another interesting thing about this eclipse, it's new and different. Well, I guess it happened once before the last eclipse in Europe, but the U.S. is expected to lose about 9,000 megawatts of solar power generation during this eclipse. But because it's occurring in the middle of the day, and this is the peak power demand in the early morning and in the evening, and it's well anticipated, everybody knows it's coming, so the utilities ought to be able to handle it without any problems.